So today we're going to be talking about solving quadratic equations by factoring and the quadratic function. So first we're going to talk about solving quadratic equations by factoring. There are many ways we can solve a quadratic equation. The first is by factoring. So there are a few steps that we need to follow whenever we are doing this. First, we have to make sure that the entire quadratic equation is equal to 0. And second, after we check for any greatest common factors, like everything's a multiple of 2 or 3, we have to factor it out and then set each factor to 0 and solve. So let's solve some by factoring. All right, so here's our first one. What we have here is x squared minus 7x minus 8 equals 10. So like I said, the first step is always to go and equal to 0. So I'm subtracting 10 from both sides. So at that point we have x squared minus 7x minus 18 equals 0. So now I'm going to factor out the number 18. 18 factors out to be 1 and 18, 2 and 9, and 3 and 6. That is a horrible looking 3 and 6. So what I'm looking for is which of these numbers have a difference of 7. Sorry, not of 2. It's a difference of 7. So now, because of the fact that the negative 7 is in fact negative, that means the factored out version will become x minus 9 times x plus 2 equals 0. Then we just set each part to be equal to 0. X minus 9 equals 0. That means x equals 9. Or x plus 2 equals 0. That means x equals negative 2. Now, I will be honest with you, I'm not going to probably do that last part. In the future ones, I'll just skip straight to x is 9 and x is negative 2 when we have numbers that are just x plus or x minus. So let's try another. Okay, so first step is that we move everything over to the right, to the left side. So 2x squared minus 4x minus 6 equals 0. Now, do we have any common factors? The answer is dividing everything by 2. X squared minus 2x minus 3 equals 0. So our factors in this case, well, because 3 only has 1 and 3, and they do have a difference of 2, x minus 3 times x plus 1, meaning our answers are x equals 3 and x equals negative 1. Okay, let's try another one. So in this case, notice I don't have to move anything over, but I also have no common factors. So when we have a leading coefficient that isn't 1, we multiply that by our constant, so 3 times 7, and that's going to equal 21. So because it was negative 7, that means that we're looking for two numbers that have a difference of, in this case, 20, and multiply to be 21. So we have 1 and 21, 3 and 7, and of course, of those, the one that has the difference of 20 is 1 and 21. So rather than just going straight to writing out the factors like I've been doing before, I have to put this in. I'm going to use the box method, 3x squared minus 7. That's my first part. And then, let's see, minus 21x plus x. And now I just start factoring. This greatest common factor between 3x squared and x is just x. Greatest common factor between negative 21 and negative 7 is going to be 7, but because this says negative, I'm going to say negative 7. Then I do it for the same thing for the other way. 3x squared minus 21 is 3x, and x and negative 7 is just 1. So our two factors are 3x plus 1 and x minus 7 equals 0. So at that point, I know x has to equal 7 as one of my zeros. For the other one, 3x plus 1 equals 0. 3x equals negative 1, which means x equals, well, you know what? Let's write this over here. X equals negative 1/3. All right, let's try this one. So in this case, it says 3x squared plus 12x plus 2 equals negative 10. So the first thing I do is I'm going to add 10 to both sides, which means we have this. Do we have any common factors? The answer is yes. We can divide everything here by 3. So we have x squared plus 4x plus 4 equals 0. Now I'm factoring out 4. My common factors of 4 are 1 and 4, and 2 and 2. Now notice in this case I'm saying plus 4, which means I'm looking for two numbers that add up to be 4. I mean that multiply to be 4 and also add up to be positive 4. Meaning, in this case, 2 and 2, so x plus 2 times x plus 2, or as I'm going to actually write it, x plus 2 squared equals 0. Meaning my only answer is x equals negative 2. All right, let's try this last one of the solving by factoring. In this case, first thing we do is we move over the 30. So x squared minus 64 equals 0. Then, hey look, these are both perfect squares, meaning we can do difference of squares. X plus 8 times x minus 8 equals 0, meaning my two answers are x equals negative 8 and x equals positive 8. All right, so that's solving by factoring. We have a second way that we need to solve, though, and that is through the quadratic formula. The second is by using the quadratic formula. Unlike factoring, the quadratic formula always works because sometimes we can't factor because it's, say, imaginary numbers or various other reasons. So let's plug in some things. So the first thing that we need to do is we need to look at the factor. It's negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Now, I'm going to tell you my first step after I get everything set up is I like to do this part first. So that's what we're going to do here. Let's try out a few example problems. So we're going to solve using the quadratic formula. Our first one is x squared minus 4x plus 3. So first thing I need to know is what are my a, b's, and c's. A is 1, b is negative 4, and c is 3. So now I'm going to find that square root of what we called the discriminant earlier in a different lesson. So let's see, my b is negative 4, so negative 4 squared minus 4 times my a is 1 and my c is 3. So negative 4 squared is 16 minus 4 times 1 times 3 is 12, which means square root of 4 or 2. So now that I know that, I can just plug these into the equation. So negative b, so negative of negative 4 is 4, plus 2, divided by, let's see, 2 times 1 is 2, or 4 minus 2, divided by 2, meaning that my two answers are 3, because 6 divided by 2, or 1, because 2 divided by 2. All right, let's try this one. Now notice, in this case, we can't actually start off just by finding a, b, and c. Because the first thing we have to do is subtract 3, which means plus 5, n equals 0. So a is 2, b is 7, and c is 5. You'll notice I didn't bother trying to find greatest common factors. That's because one of these was 2 and the other was an odd number. There are going to be no factors between those. So in this case, let's see, 2, 7, and 5, so square root of negative 7 squared, or sorry, not negative 7, I was just so used to the last one, 7 squared minus 4 times 2 times 5. So that becomes the square root of 49 minus 40, or the square root of 9, which means 3. So let's see, negative 7 plus 3, negative 7 minus 3. And all of that is over 2 times, in this case, a, which is 2, so over 4. So let's see. So that would be negative 4 over 4, or negative 1, or negative 10 over 4, which is negative 5 halves. Let's try that again. There we are. So that's how we would solve that one. Now we have one last one, and that is going to be x squared plus 9x minus 18. So there's nothing I can do for common factoring, so a is 1, b is 9, and c is negative 18. So square root of 9 squared minus 4 times 1 times negative 18. So that becomes the square root of 81 plus 72, which means the square root of 153. 153 is the same as the square root of 9 times the square root of 17. So 3 square roots of 17. Since I can't simplify that anymore, it would become negative b, so negative 9, plus or minus 3 square roots of 17 all over 2 times 1 is 2. And that would be our answer. So before we keep going, we're going to talk about completing the square next. But first, this. "'Tis a night in December when our story is told. Everyone was sleeping, both young and the old, when in through the chimney, like a fat evil crook, came jolly St. Nicholas with a twinkling look. He brought children presents, but we don't need to sneak. A computer for Susan and a skateboard for Zeke. As he went for the cookies, an elf did come down. 'Santa, we have a problem,' he said with a frown. 'No need to be worried,' said Santa. 'Don't weep. But it's all of the reindeer. They've fallen asleep.' 'Oh no,' said Santa. 'Then the holiday's doomed.'
'I have an idea,'
a small child's voice boomed. 'Who is that?' asked Santa, who'd be shocked for a week. When out from the hall was that cool kid named Zeke.
'I know the solution. Just give them Mountain Dew.'
'The soda?' asked Santa.
'Yes, new holiday brew.'
'Try Holiday Brew,'
the announcer then said.
'It's just green Mountain Dew that's been mixed with Code Red.'
So Santa did try it, and work it did right. Within seconds of sipping, the reindeer took flight. 'Zeke, you've saved December. My thanks are for you.'
'And I couldn't have done it without Mountain Dew.'
On diet, on typhoon, on tropical smash, on dewshine, on game fuel, on sangrita blast. And with a flash, she'd fly out of view, saying just, 'Ho, ho, ho!' And of course, 'Do the do!' And we're back. So let's talk about completing the square. So whenever we're completing the square, it's just another way that we can solve a quadratic equation. So to start with, I'm just going to show you a quadratic equation. And if you look, there are a couple things that we want to notice here. First off, if you look, this part right here is a perfect square because it's x plus 2 squared. This, though, is also a perfect square. It's 4. So if one of our sides is a perfect square, we don't want to solve the way we did before. We want to solve it by just square rooting both sides, which means x plus 2 would equal 4. But remember, x plus 2 would also equal negative 4 because a square root of 16 is both positive and negative, which means x would equal both 2 and negative 6. So that's the idea there. Now, we actually want to get to this specific format because if we get to this format, it's really easy. And the way that we get to this format is by completing the square. Now, I could try to describe every single step, which I've tried in the past, but I think it's honestly easier if we just actually try it through practice. So we are going to complete the square for each expression to create a perfect square trinomial. Then we're going to factor the expression. So whenever we have an expression like this, we are looking for the third part to complete our square. So here's how we figure it out. We take our b value. In this case, our b value is negative 12. So negative 12 divided by 2 is negative 6. And negative 6 squared is 36. So it becomes plus, let's try that again, 36. Now, that's our first step. Our second step in this case is we have to factor the expression. Now, if I was to factor it, I'd say what are two numbers that multiply to be 36 and add up to negative 12? But what we're going to discover is it ends up becoming x plus our b value, or b over 2, which is negative 6. So this part matters quite a bit once we get to this point. And that's our factored version. Let's try it again with this. So in this case, we have 2. 2 divided by 2 is just 1. And so 1 squared is 1. And our factor would become x plus 1. That's the idea. Let's try one more. This one says 5. So 5 divided by 2 is 2.5, but I would rather just leave it as the fraction, at which point we're going to square it. 5 over 2 squared becomes, well, you have to first square the numerator, so 5 squared is 25. Then square the denominator. 2 squared is 4. So this becomes 25 over 4. Now, whenever we actually factor it out, we end up getting x plus 5/2 squared. So that's our idea. Now, we're going to actually use this ability to solve quadratic equations using this. So, our first step when we're wanting to solve quadratic equations is get to where we have an empty space right here. The problem is it's not currently empty. It currently says 11. So, what we do is we first take away our original c value. So it becomes equals negative 11. Now that we know that, I go and I find my b value, which is negative 12. So negative 12 divided by 2 is negative 6. Negative 6 squared becomes 36. If I add 36 to both sides, I end up getting to factor. So when I factor, this would become x minus 6, because that's what we had over here squared, equals negative 11 plus 36 is 25. Let's rewrite that 25. Then I just square root. The square root of both sides, x minus 6 equals 5, and let's rewrite that 5, and x minus 6 equals negative 5. So if I add 6 to both sides, x equals either 11 or x equals 1. All right, let's try this one. All right, let's look at something. And I'm saying all right, I know, a lot I know, but notice we currently have this nice, big, greatest common factor. We can divide everything in here by 3. So this becomes x squared minus 3x minus 10 equals 0. So at that point, we're completing the square by going x squared minus 3x equals, in this case, 10. And then negative 3/2, meaning that we'll actually add 9 over 4 to both sides. All right, let's talk about our factoring. This becomes x minus 3/2 squared, and that's going to equal 49 over 4 when we work out what 10 is, because 10 is 40 over 4. So then I square root. So let's see. Our first answer is going to be x minus 3/2 equals 7 over 2. And I would add 3/2, meaning 10 over 2 or 5. Our second answer is x minus 3/2 equals negative 7 over 2. And I would subtract 3/2, and I would add the 3/2, again, and that becomes x equals negative 4/2, or x equals negative 2. So that's the idea. Our two answers are 5 or negative 2. Okay, let's try one more that we're going to do. First step, like always, is move over the c. So x squared minus 4x equals negative 24. Now, in this case, what I'm going to do is I'm going to take negative 4 divided by 2. That's negative 2, and negative 2 squared is plus 4, so I'm adding 4 to both sides. Now, what we end up getting here is x squared minus 4x plus 4 equals, oh wait, let's actually just factor that one out. That becomes x minus 2 squared equals negative 20. Then I square root both sides. X minus 2 equals, the square root of 20 is going to be a little bit harder. That ends up becoming the same as negative 1 times 4 times 5. So that becomes 2i square roots of 5. So at that point, and that's plus or minus. Now, because we can't factor it out at all, it just becomes x equals 2 plus or minus 2i square roots of 5. And that's our final answer. Okay, so there you go. That's it. Thank you for watching. If you want to watch the video that was in the middle of this, you can. It will be a link in the description, as well as I should have one right up here now. So there you go. Thank you. If you need any of the prior things that we learned, go and search for those videos on my account. Thank you very much. Goodbye.